Hi everybody! In today's video, we're going to go over some problems that you learned in your math class last week. Number 1 says, which line appears to contain all of the ordered pairs in the table? So remember, an ordered pair is just a way to describe the location of a point in the coordinate plane. Ordered pairs are always written with x first and y second. So when we see a table set up with x and y, that's just another way to write an ordered pair. It's just organized differently. So this is the ordered pair -2, 4. This is the ordered pair -1, 2. And this is the ordered pair 0, 0. So what this question is asking us to do is figure out which blue line, A, B, C, or D, has all three of these points on the line. So let's start with the first point, -2, 4. Remember, your x point is first, so our x coordinate here is -2. Your x-axis is the horizontal axis, so that's either to the left or to the right. Starting from the origin, if I want to get to -2, I'm going to go left 2. My y value is +4. So from here, my y value, my vertical axis, is how far up or down I need to go. If it's a +4, I need to go up 4. So I go up 1, 2, 3, 4. And this is where the ordered pair -2, 4 would be. That's that point. That is not on this line at all. So A is going to be not a good choice. Let's check out B. So again, when we're plotting points, we start at the origin, and we're going to look for -2, 4 to be on this blue line. So since my x value is -2, I go left 2. Since my y value is +4, I go up 4. 1, 2, 3, 4. This time when I plot the point, I notice that I am on the blue line. So B could be a good choice. Let's take a look at C and plot -2, 4. So I go left 2 and up 4. Oh, definitely, oops, a little off there with my pen, but definitely nowhere near this blue line. So C is a bad choice. And last, let's check D. To get to -2, 4 from the origin, we go left 2 and up 4. And again, that is just nowhere near this blue line. So the only line that has the point -2, 4 is B. To be sure that it works, we also need to check to make sure that the point -1, 2 is on the line and that 0, 0 is on the line. We already know that -2, 4 works. That's here. 0, 0, well, that's my origin. That's right here. And again, it's on the line for B, so that works. So now we just check -1, 2. So when my x value is -1, we go left 1. Our y value is +2, so we go up 2. And that point is on the line, so B is our best choice here. Let's go to the next question. Number 2 says, which equation represents the ordered pairs in the table? So check out the table first and always look for the pattern between x and y. What is happening to x to give you y? So 2 becomes 6, 6 becomes 18, and 10 becomes 30. Do you notice something that's the same about all three of those rows? So now let's look at our equations and see if that can help us figure it out. I notice that each equation is set up in the form of y equals some number times x. So A says y equals 1/3 times x, B says y equals 3 times x, C says y equals 4 times x, and D says y equals 12 times x. So our job is to figure out which rule is working every time for this table. What number times x gives me y every single time? Is it 1/3, 3, 4, or 12? Well, mental math might tell you. You might know right away what we're multiplying by, but if you don't, you could use Desmos to help you. So the first equation A says y equals 1/3 times x. My first x value is 2. So when I do 1/3 times x, or 1/3 times 2, I want my answer to be 6. So let's see if that works. So we type in 1/3, and I'm going to multiply it by my x value, which is 2. And I want my answer to be 6. My answer was not 6, so that means that A is not a good choice because 1/3 times x did not give me y. Let's check B. B says y equals 3 times x. So I need to do 3 times 2 and see if that gives me 6. And it does. So 3 times x works for the first row because 2 times 3 equals 6. Let's see if times 3 works for the next row. Well, I know that 6 times 3 is 18, but if I didn't, I could check in Desmos. It works there as well. And I need to see if it works in the last row. Oops. So I want to check to see that 10 times 3 equals 30. And I know that that's true. So B, y equals 3 times x is my best choice here. C wouldn't work because it says y equals 4 times x. And I know that 4 times 2 would be 8. D says that y equals 12 times x. And I know that that won't work because 2 times 12 would be 24, and that says 6. So B is the best choice here. Number 3 says, directions. Drag and drop the correct answers from the options below. So the options below are all of these blue boxes here. And the question says, a line contains the points represented by the table of values. So here's our table of values. You're looking at the connection between x and y, x and y. And the blanks we have to fill in, the things we need to drag and drop, are the slope of the line, m, is blank. And we also have to tell it the equation of the line is blank. So this question is asking us to find two different things here for this problem. First, it wants us to identify the slope of the line. And it tells us that slope is m. So looking at my choices below, I know that I'm going to pick one of these three that say m equals for this first box. The next step says to tell us the equation of the line. So I know that if I want to fill in the equation, I'm looking for y equals something, and I want to know what is happening to x to give me y. So one of those three equations is going to go in this second box here. So now how do we figure this out? Well, our slope of the line is the number that we're multiplying by. We're looking for the pattern between x and y. So what is happening to x to give me y? I can use the choices to help me. All right, so it says y equals x plus 4, x plus 1, or 4 times x. So what's happening between x and y? Does plus 4 work? 2 plus 4 would be 6. So no, this does not work. So I can eliminate that. The next one says x plus 1. 2 plus 1 would be 3. So no, that does not work. And the last one says y equals 4x, which means 4 times x. So what's 2 times 4? Well, that would be 8. So let's check the next row and make sure it works. What's 3 times 4? Well, 3 times 4 is 12, and I could use Desmos to check if I wasn't sure. And what's 4 times 4? Well, 4 times 4 is 16. So I think that the equation of this line is y equals 4x. Because every time here, if I multiply x by 4, it gives me y. So now what's the slope of the line? So remember, the slope is the number that we are multiplying by, and the number we were multiplying by here is 4. So the slope of my line is m equals 4. Another way you can find your slope is by taking the change in y and writing it over the change in x in your table. So your change in y from 8 to 12 is 4. Your change in x from 2 to 3 is 1. So you could write that as 4 over 1, which is just equal to 4. So that's another way you could have found your slope. Question number 4 says, which statement identifies the slope of the line and the ordered pair of the point on the graph? So it wants us to match up two things. It wants us to find the slope, which is our rise over run, so like the steepness of our line, how far up and how far over we go every time to get to different points on the line. They also want us to identify the ordered pair of the point on the graph. And here's the point, they marked it for us in blue. So we need to figure out what that ordered pair is, or its location in the coordinate plane. So let's start with the ordered pair, and we can use that to help us eliminate some choices. So remember, when you're plotting a point in the coordinate plane, you always start at your origin, and your x value comes first, followed by your y value. Ordered pairs are always written in this order, x comma y. A quick way to remember that is that x comes before y in the alphabet. On the picture, it reminds you that this horizontal axis here is your x-axis. They wrote x next to the 5. And they reminded you that this vertical axis here is y. They wrote it next to the 5 up here. So if you forgot, the picture might give you a hint. So from my origin to get to this point, do I need to go left or right? I need to go right. So let's count how far right we need to go. 1, 2, 3, 4. I went right 4, so my x coordinate is going to be positive 4. From here, to get to my point, do I need to go up or down? I need to go up to get to this point. How far up do I need to go? 1, 2. So my y value is a positive 2 because I went up 2 units to get to this point. So the ordered pair of this point up here in quadrant 1 is 4, comma 2. So right away I notice that A has the ordered pair 4, 2, and B has that ordered pair, but C and D have it written backwards. They have the ordered pair wrong. So my answer can't be C and it can't be D. So that narrows it down to A or B. A says the slope should be 2, and B says the slope should be 1/2. So let's go to our graph and figure out what our slope should be. It's helpful when identifying the slope to put some more points on your line. When you're looking at the slope, you're counting your rise and your run between points on the line. So here's another spot where I could put a point. Now that I have a couple points on my line, I can count my slope. Your slope is your rise over run. Now think of that word rise. That's going to be how far up we are going from point to point. And our run is going to be how far to the right we move from point to point. So I'm going to set it up here. I'll put my rise in the top and my run in the bottom. So starting at the origin, to get to this point, how far do I need to rise? How far up on the y-axis do I need to go? Well, I'm going to go up 1. So my rise here would be 1. And to get to the point, how far do I need to run? Well, I need to go right 1, 2. So I ran 2 units to the right. So my slope here is 1/2. So the best choice here is B because it has the correct slope and the correct ordered pair. A said the slope was 2, which was not quite right. Question number 5 says, which graph has a slope of 1/2 and passes through the point with the ordered pair of -4, -2? So we have to check for a graph that has both of these things. We're looking for the slope of 1/2 and the ordered pair of -4 and -2. So our graph would need a rise of 1 and a run of 2 from one point to the other. We're also looking for an ordered pair of -4, -2. So let's start there. From my origin to plot the point -4, -2, my x coordinate is -4. My y coordinate is -2. So I need to go left 4, since my x value is -4, and down 2. And that's where the point -4, -2 would be. Is that on this line for A? No. So A is a bad choice. Let's check for the point -4, -2 in B. From the origin, I go left 1, 2, 3, 4, and down 2. That is on the line at B, so I can't eliminate choice B. I have to check the slope. Let's go to choice C. I need to go left 1, 2, 3, 4, and down 2. That is not on the line, so C is a bad choice. And from D, I start at the origin. I go left 4 and down 2, and that point is not there, so D is also a bad choice. So without even checking for the slope, and just by checking for the ordered pair, The only line that works is choice B. So let's check out the slope of this line though. Let's check out our rise and our run here to make sure we have a slope of 1/2. To do that, I need some points. So I'm going to put a point here at 0, 0, and another point on this line. It's right here, and I see another one here. So now I'm ready to count my rise and my run, how far up and how far to the right I go. So I go up 1, and I go right 1, 2. I can count it again from this point to this point. I rise 1 and I run 2. So every time rise over run was 1/2. The last question is a spiral review to inequalities. So number 6, which of the following values satisfy the inequality shown? You must select all that apply. Don't forget when it says select all, that means there's going to be more than one correct answer down here. So first we need to solve this inequality, and then when we get our answer, we can think about all the possible solutions that would be true for x. So just like when you're solving equations, I like to separate my inequality to a left side and a right side. And remember, our goal is to solve for x. So ask yourself, what operation is happening to x in the problem? I see negative 5x, and I know that means negative 5 times x. So the operation we have here is multiplication. What is the opposite of multiplication? Oops. I know that the opposite of multiplication is division. So to solve for x, I'm going to divide on both sides of my equation. Now, what do I want to divide by? I want to divide by that number in front of x, the number that x is being multiplied by. And that's going to help me get x by itself. So what number's in front of x? Negative 5. So we're going to divide on both sides by negative 5. Anytime you multiply or divide by a negative, the first thing I want you to do is take your symbol and flip it. So I want to take this symbol here and flip it around so that this stays true. If I don't flip the symbol, then my answer is going to be wrong. So now let's go ahead and finish solving. Anytime you do a number divided by itself, it equals 1. And since I have just one x, all that's left over is that x. I'm going to bring it down. 35 divided by negative 5. I can either do this in my head or use Desmos to help me solve. 35 divided by negative 5 is negative 7. And so my answer right now looks like this. So what does this say? This is telling me that x is less than or equal to negative 7. X is less than or equal to negative 7. So what does that mean? That means x could be equal to negative 7, x could be negative 7, or x could be everything less than negative 7. So looking at these choices, I need to pick all numbers that are equal to negative 7 or less than negative 7. So right away, I want to pick negative 7 because that's part of my answer. But I also need to pick everything that's less than negative 7. So if you're having a hard time remembering which way negatives work, remember anytime you're looking at your negative numbers, zeros in the middle, your positives are this way, so let's call this positive 7. And your negatives are to the left, there's negative 7. Remember, as you move to the left, everything is getting smaller, everything is decreasing. So numbers that are further to the left of negative 7 are going to be less than negative 7, like negative 8 and negative 9 and negative 10 and so on. So numbers in this chart that are less than negative 7 would be negative 10. Negative 5 is going to be here. It's going to be actually to the right of negative 7. It's closer to 0, so that's not less than negative 7. It's greater. Negative 14 is to the left of negative 7, so it's less. Negative 3 is not. And positive 1, well, we know all positives are more than negatives, so that's not going to be a choice there. So those three choices are all correct values for x because they're all less than negative 7 or equal to negative 7. I could plug them back in here and they would make a true statement. So for example, instead of writing x is less than or equal to -7, I could say -10 is less than or equal to -7. And that's a true statement because it's less than. -7 is less than or equal to -7. That's true because it's equal. And -14 is less than or equal to -7. And that's true because it's less than. All right, that's it for today's review. Thanks for participating.